In this presentation, we are going to talk about factoring a sum or difference of cubes. Difference of cubes factoring states that a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. If you want proof of that, just expand out a minus b times a squared plus ab plus b squared. You get 6 terms, but then after you collect like terms, you end up with just a cubed minus b cubed. Similarly, sum of cubes factoring states that a cubed plus b cubed is a plus b times a squared minus ab plus b squared. If you want proof of that, expand out the right-hand side. You get 6 terms, collecting like terms, then you end up with just a cubed plus b cubed. So what if we were asked to factor the expression x cubed minus 125? Well, we could recognize x is, of course, x cubed. 125 is 5 cubed. And so we would get a minus b, letting a be x and b be 5. A minus b would be x minus 5. A squared plus ab plus b squared would be x squared plus x times 5 plus 5 squared, which is, of course, x squared plus 5x plus 25. We always want to state that second factor simplified. How about if we were asked to factor the expression b cubed plus 27? Well, this is a sum of cubes opportunity, and we can recognize b cubed plus 27 as b cubed plus 3 cubed. Well, that's b plus 3 times b squared minus b times 3 plus 3 squared, just using our formula. And that becomes b plus 3 times b squared minus 3b plus 9. If we were to expand that out and collect like terms, we would end up with b cubed plus 27. Now, what if we want to factor a more complicated expression like this? Well, we might recognize here that we've got a sum of cubes. The way we can recognize that is because our coefficients are perfect cubes and our exponents are all divisible by 3. At this time, it's worth mentioning that it's good to know the perfect cubes. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216. It's good to be able to recognize these and have that kind of number sense. And when the exponents are all divisible by 3, that combination of facts lets us know, hey, we might have a sum or difference of cubes here. Well, if I let a be 2x squared and I let b be 3y cubed z, then a cubed is 2x squared times 2x squared times 2x squared, which is 8x to the 6. And b cubed is 3y cubed times 3y cubed times, 3y cubed z times 3y cubed z times 3y cubed z, which is 27y to the 9z cubed. And so letting a equal 2x squared and b be 3y cubed z, our original expression is just a cubed plus b cubed. So it factors into a plus b times a squared minus ab plus b squared. Plugging in 2x squared for a and plugging in 3y cubed z for b, we get 2x squared plus 3y cubed z in the first bracket. The second bracket is 2x squared quantity squared minus 2x squared times 3y cubed z plus 3y cubed z quantity squared. And simplifying that, we get the expression shown where the second factor is 4x to the 4 minus 6x squared y cubed z plus 9y to the 6z squared. Now we have another opportunity here. We can factor this expression as by first recognizing that we should common factor. Always common factor first, CFF. CFF is your BFF. When we factor out 3wx squared, we end up with 64x to the 6 minus 125. Well, 64 is a perfect cube. It's 4 cubed. And 125 is a perfect cube. It's 5 cubed. And our only exponent left in that bracket is 6, which is divisible by 3. Well, now that means we're going to have an opportunity for difference of cubes here. Letting a be 4x squared and letting b be 5, we have a cubed minus b cubed in the second bracket, in the second factor, which is, of course, a minus b times a squared plus ab plus b squared. Plugging in 4x squared for a and 5 for b, we see that 64x to the 6 minus 125 is 4x squared minus 5 times 16x to the 4 plus 20x squared plus 25. Of course, you have to simplify that second factor. But don't forget the original factor that we common factored out of 3wx squared. So altogether, the original expression factors to this. And that's the end of that slideshow, and we'll talk about the rest of it in another video.